I'm going to talk a little bit about what's going on in Europe right now. I'm going to give you the perspective from Europe and my perspective from Norway, and a little bit about what we are doing in order to make a renewable system in Europe. And I think it's quite connected or quite relevant for the rest of the world as well. My daily operation is like I'm working as a professor at the Norwegian University of Technology and Science, but I also have are running large projects together with partners in Europe. So I have the possibility to work together with partners in. Right now, I'm working with partners in Sweden, Germany, Scotland, and Italy and France. Let's see here. I'm going to talk about what's going on in Europe, but I'm also going to talk about a little bit about the transport sector, which is really one of the challenges when it comes to renewables. How can you implement renewable energy to the transport sector? How can you get rid of the fossil fuels? We are living in the same world, and we have to do everything in our daily life in order to make it better. Because what we're going on right now is nothing less than a catastrophe. We have to make sure that the renewables or that the temperature is not rising too much. I'm living in Norway, a country in the outskirts of Europe. We have cold winters, short summers. Right now, for me, this is in the morning, 8 o'clock more, and I have minus 15 degrees Celsius outside my house. I'm living in the middle of Norway. So you see, relative to Nepal, I'm quite north. Days are short. Daylight, I have only four hours of daylight today. I'm living in an apartment in all of these houses next to the river passing through my hometown, Trondheim. The houses are well insulated, and I can maintain an internal temperature of 20 degrees at all times. Regulations in Norway says that it has to be a minimum 20 centimeter of insulation in the walls, and most of the houses has double glassing and insulated doors, somehow triple glassing as well. Even the old houses you see here, they are more than 100 years old. They have been modified so that the insulation are good. I have to sort my garbage in different types. So my municipality can recycle it. Glass, paper, batteries, metals goes in separate garbage cans. And in the future, I will sort the waste as well. The waste, food waste, in other words. I'm driving a car, an electric car, a small one. And I have charging station relatively close by. I have a charging station in my garage, but along the main roads, it's never more than 50 kilometers between the intensive high charging stations. We have introduced electric buses in my hometown, and in 2025, public transport will have to be without emissions. What you see here is an electric bus. But it means in the future we will both have hydrogen-driven buses, trains, boats, and ferries. And we have these ones, and they are all over now. And I can use them back and forth to job. I can order them from my smartphone, and I know where. And on the smartphone tells me where I can find it. I'm not living like this because I'm especially focused on being environmentally friendly. It's because our politicians have decided that we have to do what we should do to have a sustainable world and to protect our planet. I believe you all have heard about the Paris Agreement. This is the setting with boundaries and forcing changes to our way of living. And of course, the Western world and Europe should be ahead of it. What you see here is a roadmap that shows what we are doing in Europe, or what we have been doing so far. And it goes from subsidies to taxes of emissions. The taxes will, at one point in time, be so high that renewables energy is the cheapest solution. Today, we see that renewables are sometimes cheaper without subsidies. That is really a win for renewables. European ambition is like this. We are targeting 32% renewables within 2030. And it has to be carbon neutral by 2050. But 32% within 2030 is quite a tough ambition. Today, we are around 15–16%. Some countries more than others. This is an illustration showing how we see the system in a whole. It applies to small and large cities. The thermal power plant you see here is burning waste or biofuel. The three main renewables are hydro, wind, and solar. And in this case, hydro is a backbone of the energy system. Without it, we cannot add solar or wind. We can't control it. So what we are saying here in Norway and in Europe is that hydro is the enabler of other renewables, especially solar and wind. The houses are smart, meaning it has solar panels on the roof, batteries in the basements, charging station in the garage, and it is controlled in such a way that the energy consumption is taking place when the energy price is low and high power peaks are avoided. Meaning my control system can turn on and off my charging on my vehicle because we need energy or power elsewhere. That makes it smart. Right now, the power capacity in Europe is like this, but you see that hydro is among the highest ones, and but wind and solar is really taking off these days. We'll see that wind will pass installed capacity of hydro within a couple of years, and solar is coming right behind it, meaning it will be more intermittent energy available and operating, and that is a challenge to the system, especially when you turn off all the other fossil fuels and nuclear power stations. A hydropower system in Norway or northern part of Europe looks like this. A typical plant has a reservoir upstream, tunnel, power plant, and outlet to the downstream river or lake. We look at the reservoir as our battery. If you look at the tunnels though, in Norway, altogether we have 4,500 kilometers of tunnels. And that is not small tunnels. We're talking about tunnels with a diameter of 10 meters in diameter and larger. 4,500 kilometers. That's a lot. So the Norwegian mountains are like Swiss cheese. The hydropower capabilities, or it has unique flexible capabilities. It can give a quick response to any changes in the net. It can stabilize the frequency and the voltage. It can store a lot of energy in its reservoirs, and it can give flood control, and it can also have drought mitigation. On top of that, it is a clean and efficient and scalable both in time, capacity, and energy. So it is the ultimate way of utilizing our renewables. This is Blåsjø Reservoir. That's the largest one in Norway. It has a storage capacity of 7.8 terawatt hours. It is a huge battery. But let me illustrate how huge it is. I'm not sure if you have seen the Tesla Powerwall. The Tesla Powerwall is a small battery that can be installed in our houses. Relatively small. It can store up to 14 kilowatt hours. Well, if you look at this, if you take the number of Tesla Powerwalls that is in this reservoir, it is 5 million of them. And if you stack them side by side, it goes 12 times around the equator. So utilizing reservoirs as a battery is a huge possibility and for many countries in the world. However, you need to maintain the environment also. You're not stepping in on or changing the environment too much, but it is a lot better than many of the other alternatives. So let's look at how we in Europe are going to utilize our reservoirs. One typical reservoir in Norway is like this. Sirakvina has, you see that the reservoirs, there are small reservoirs from the top, and then you have a tunnel and a power plant and another reservoir, tunnel, power plant, and then goes down to the lower reservoirs. Today, water is flowing one direction. And the storage capacity for Norway was intended to have a storage capacity during winter time when the snow is running. So right today, for example, our energy is coming from the reservoirs where we have stored water. In other words, our batteries. The future will have, we need to introduce a more flexible operation of these power plants. And for us, it means that we need to install pump storage. A pump turbine is simply, a pump storage power plant is simply a machine that can act as a turbine when energy system needs it, and it can operate as a pump when we have excess energy available. So for example, when it blows a lot in Denmark, for example, and they are not utilizing the energy, we can import it into Norway and we can pump water from the lower reservoir up to the higher reservoir. It is simply, a pump storage system is simply look like the same as a hydropower plant. It's the machines that are different. So a Francis turbine is a pump in reverse, actually. So if you take a Francis turbine, you can change the geometry of the turbine itself to a pump turbine, and you can utilize the generator as a motor. And by doing that, you have a pump storage, a pump turbine system. And that adds flexibility to the system. For example, in this system, we could add a pump in the lower power plant, Tolstad, this one, and we can pump water up to the upper reservoir. And we can do that with all power plants. Of course, there are challenges, technological challenges to it, but it is possible. And that makes the system highly flexible. We can add a lot more power to it, and we can even buy energy cheap when it is available from other parts of Europe. So let us see what happens in the other renewables there. I will use wind and solar as examples. In Norway, we have installed a lot of onshore wind power plants, and we are installing offshore wind power plants. To the right here, you see a floating system, and that is a Norwegian innovation, and it's named Hywind. And the point is that we are going to utilize large areas in the sea as well. Take a look at the waters are surrounding Europe. It's quite a lot, but sometimes it's hard to imagine whether this could be could take all the energy needed in those countries. Let me use Norway as an example. If I'm going to take all energy needed in Norway from offshore wind power plants, I need an area, and it is an area of 160 by 160 kilometers. That's what we are talking about. And the square you see in the ocean outside Norway is the size of area I need in order to supply all the energy needed in Norway. Everything, including the transport sector. Which in other words means that there are a lot of energy available from the oceans, from the wind energy over the oceans. And because of this, we have seen a huge development of wind turbines over the last few years. In 1976, I think the biggest turbine at that point, it was 15 meters in diameter. Today, the biggest one that is commercially available is the GE Harley X. It's 220 meters in diameter. It's a huge machine. And now on the drawing board for the researchers, we see turbines up to 250 meters in diameter and bigger. Just imagine the problem of transporting these blades along the roads. It is a problem. It is a challenge, especially when it comes to corners. It is not, when it comes to the largest one in Norway, I think we have reached a limit. It's hard to bring them inland because of the transport. Some of them are quite innovative, so they transport it like this. And I think this way of transporting would also be able to do, you could do it in Nepal as well. But it is a challenge to do it inland. So the largest one, I think we will see, will be developed and built in the seas, and it's easier to transport it with industry in Europe, and it is developing rapidly. And as I said, it will be with more power installed than hydro pretty soon in Europe. When it comes to solar energy, it is again an industry that grows quite fast, and this one is also booming very fast, and it's getting cheaper and cheaper. I was a little bit skeptical about this, the solar energy. I didn't think it would be possible to implement it here, especially because we are that far north and we don't have sunlight very much in the wintertime when we really need the energy. But we are installing floating solar panels in Norway as well. Outside my hometown, they are now testing a floating system, just like the one you see on the right-hand side here. But it's more and more common now to install it on the roofs of our homes, together with a small battery, and we have charging station, and so that is some houses is actually self-sufficient with energy. Like this one, for example, it is a commercial building just been built, and you see solar panels on the roof and on the walls as well. And it actually produces all energy it is needed inside that building, and sometimes it is even exporting energy. So that's quite a challenge, quite an achievement in my opinion. But what about the transport sector? Airplanes, large boats, trains. What is going on there? I think hydrogen is an alternative, and also electricity. Electrical vehicles we see everywhere, and that has changed quite a lot in the last few years. If you look at the cars that has been developed, more or less every car manufacturers have come up with their car. I really like them. They are cheap, they are fast, and they are fun to ride. My favorite is the Tesla still, but we see them all over, and they are really good. They are really good. In Norway, 20% of all cars are electric these days. I think last year 50% of the new cars that was sold was electrical, and after 2025 we are not allowed, or we're not allowed to sell any fossil-driven cars. Meaning, within 10 years from now, we will see most electrical or hydrogen-driven cars in Norway, and that is the same with Europe. I have one fun fact though, is that Harley Davidson, they made an electric bike, the live wire. and the nice thing about it is that they actually have a speaker on it which can give the sound, which is the Harley Davidson sound. So if you like, you can add on that feature as well when you buy that car, buy that bike. So imagine ultra-conservative Harley Davidson had to go in that direction as well, meaning that everywhere you'll see that development now coming up. The high-capacity charging station, I think the ones we see now is up to 10 kilowatt to 20 kilowatt, and it's coming to 50 kilowatts in the future, meaning my car can be fully charged in half an hour. So I can have a cup of coffee and then it's fully charged. Europe is building these stations everywhere now. And at my university, we are doing research on wireless charging stations on the road. We are utilizing induction to do that, meaning you can just park one place and you get charged. And in the future, we see that we can even add it in the roads. So when you're driving, you're charging at some places. I didn't think about it just a couple of years ago, but today we are seeing that this is possible. Hydrogen is coming now with full power. It will cover 25% of the world energy consumption in 2050. That's what they are saying. And the production of hydrogen needs a renewable energy source. Wind, hydro, sun could be good alternatives. So hydrogen and electrical vehicles are the things we are seeing in the future. Let's take a look at the airplanes. So electrical batteries are today too heavy to utilize in large airplanes. So they are looking into how to utilize hydrogen as the energy source. So by 2035, Airbus wants to bring the world's first emission-free passenger aircraft to the market. And they are looking into two ways of utilizing hydrogen. One is to modify the gas turbines, so they use hydrogen as a fuel. And the second one is to use fuel cells to produce electricity, and then an electrical motor that drives the fan or propeller. So it's coming, and we see test flights already going on for the smaller airplanes. The large boats is also coming with hydrogen, and again, ABB in this case has plans for a hydrogen powertrain on large ships, and they will also utilize use fuel cells that produce electricity to electrical motors that then drives the propellers. The challenge with hydrogen is the transportation or distribution, but it is available. It's possible to do it. In sometimes they are producing ammonia, so to distribute the gas. So first, wind and solar and hydro is then producing hydrogen through electrolyzer. They add nitrogen to it, and then it becomes ammonia. Then they distribute it to wherever they need it, and then it brings it back again to hydrogen, and then put it into the vehicles needed it. And that can go into trains, airplanes, boats, whatever. European emission is now quite high. They just announced that hydrogen electrolyzers will be at least 6 gigawatts within 2024. So meaning 6 gigawatts of renewable energy is going to produce hydrogen by 2024. That's only 3 years from now. By 2030, 40 gigawatts is going to be produced. 40 gigawatts of renewable energy is going to be utilized for electrolysis. And they're going to produce up to 10 million tons every year. And we see that the share of hydrogen in Europe will be up to 14% by 2050. That is a huge part of the system. I believe it's possible to make the energy system fully renewable, and the transport sector based on fuels generated from renewables. But new innovations are needed to have such an integrated system. It is you and it is me who should make this work. We are the engineers. Thanks.